fix it later was a viable approach in the past, but today those original premises no longer hold. Fix it later is chaotic, it's old school. We can't do that anymore. The old premises were, we can fix it later because performance problems never happen, and we all know that's true. Hardware is fast and inexpensive now. The cloud has unlimited potential. It's too expensive to build responsive software because we have to spend time on it. We have to pay people to do it. And also, you can always tune it later. Just release it to production now. It's better to get working code because that's what money sounds like, cha-ching, right? Have any of you heard any of that kind of lingo from people in meetings? Does that sound familiar, especially from management?
How many of you believe it?
Well, you know
what? I
what?
don't see any hands going up.
That's not an old idea. It was written in 1990 by a book by Connie Smith called Performance Engineering and Software Systems. This is not a new villain we are fighting against, okay? So don't think that you're alone. But this mentality still exists. However, changes will be forced upon us all because the cloud will be the great leveler, and you'll find that out more as we go.
Very rarely do we have a time where our skills and our capabilities are coincident with executive management's desires. And their desires are move to the cloud, cut costs. Costs are directly related to how resources are being used in the cloud. Sparse resource applications are highly efficient. That's what we want. So we now have a time in history, one of the very few, where our specific discipline is highly coincident with executive needs.
How many of you have been hearing about Web 3? How many knows what Web 3 is? If you do, yell out what you think Web 3 is. Is it Bitcoin?
It's the semantic web.
It's crypto. Yeah, we're going to trade crypto. We see how good that's been. It's NFTs. We're going to make drawings and sell them for Bitcoin and trade it for... Is that Web 3? Well, sort of. Not really. So how many of you are very familiar with blockchain and how that technology works at all? Or just however. That's really the place that you need to start. So that's the fundamental building blocks of Web 3. So let me tell you why this is important for performance engineers. Web 1.0 was, it's really cool that we can get all this crap on the internet for everybody to look at because we got web pages and images of cars and images of stuff, and everybody wants to go check out all this stuff and share information and get online forums. And that was cool, but that didn't really make a lot of money. So the Web 2.0 was to make a richer experience, but now let's start offering services where you become the product, and we will take your information and sell that to marketing companies that will make buku money off your information. And that has rubbed a lot of people the wrong way. Privacy, security. I want to own my own data. If I want to use your platform, that's great, but if you make me mad and I want to take myself out of your platform, I should have the right to remove that because I own my own identity. That's the fundamental premise of Web 3, is taking ownership of what you own and your identity and be able to remove it from that and make it distributed enough that you can take it away. So think about, it's the same as Web 2.0. The technology stack is still there. It's still HTML and JavaScript and all the things that you test today, but what happens is that underlying layer are the same fundamental layers as blockchain. Distributed systems that have to have proof of work and proof of ownership to make transactions happen. A ledger that is shared amongst everybody so nobody can cheat, right? And that you have to basically deprecate old versions and everybody agrees to go to the new one. It's cool in a sense, but from an performance engineering standpoint, it's very slow and it's very hard to make that thing speed up. So there's going to have to be tricks and techniques that they build to make that faster.
This concept of agreement.
That's right.
Of 50% plus one of the nodes. Think of that from a network perspective, and you have a network spread over in the entire planet. Now, some solutions are easier. You have, say, a private market solution. Say you're tracking beer ingredients. in that particular industry, from where they're grown to the beer they go in. You can have a private blockchain for that. You can reduce the number of nodes. But for this public information problem, it is very complex from a network perspective to get that agreement. And what happens, say, if one government wants to turn on enough computers so they have 50% plus one nodes, as China did with Bitcoin a while back, and they were punished for that. But if it's not coin-based, what if it's just private information-based?
What if it's your healthcare information? And Nashville has a very vibrant blockchain community here, and crypto, what they call it, decentralized finance community here. Zach Cole was actually going to be here tonight, but he couldn't make it, so I wanted him to talk about that. But there's a whole community around that here, and people are moving here because of that. So you will hear more about that in this town over the next 2 to 3 years. So if you're not messing with it now, look for it.
How many of you have gone to a web page and found that it has 500 elements on the page, and it has 6 megabytes or more associated with the size of the page? That's a lot of activity going back and forth. That's frequency, that's size. So these are really the dimensions of performance. CPU, disk, memory, network, when you allocate, how long you hold on to it, how large it is, and how often you hit it. And if you can minimize those dimensions of performance for all of your resources, you will have a very high performing application. It will be very efficient.
Where do we get the value out of performance testing?
The value added in performance testing is in analysis. It is not in the creation of the data.
So hold on just a second. You said the value is in the
analysis.
Can you think of any load testing tool that doesn't have a very robust analysis engine that you have to have another tool to do analysis with?
That's the whole open source universe.
I won't name any names, but
yeah.
Sorry.
80% of the gains that you can find in performance can be found just in making sure that your application scales for one user. Think of all the decisions you have to make for how you stage resources, how large they are, how efficient the queries must be to the data storage. Bringing all that together, making sure it scales for one. Because if it doesn't scale for one, it sure is not going to scale for many. It may scale for many.
So what that might mean is you might save yourself a whole lot of time when you get that new application that you're going to have to test and it's web-based, and you walk up to the web page and you go, hold on just a second. Let's open this up in Chrome. Open up Chrome Dev Tools. Open up Network. Open up Performance. Run the page. Now what was the service level agreement on this page? 5 seconds? Okay, I'm running it. It's 8 seconds. We don't even need to run a test. It doesn't scale. That's performance engineering versus performance testing. I don't need to run a test to tell you suck. Here's what you need. So let's fix that first before we get out of the gate. Send it back to developers to fix that first. When they've done that work, oh, well now, that's what you're checking? Oh, that's Dev Tools. I'm surprised at how many developers do not know about Chrome Dev Tools and the tabs that are available. One of them called Performance.